Okay, data and programs stored in memory. Memory is separate from the CPU, and instructions and data piped from memory to CPU. Basis for imperative language, that is variable model of memory cells, assignment statements, model pipelining, and iteration is very efficient with the John von Neumann architecture. So today we'll discuss about how the John von Neumann architecture was very suitable for the imperative programming languages. Okay, so let's see, go to the next slide. So here, this is the John von Neumann architecture, that is the processor, the central processing unit. It is the central processing unit, or we can call a processor, and it is the input and output devices, they are connected. And here this is the memory. Memory means that is the primary memory, right? This is the memory means that is the primary memory. So the primary memory having both data memory as well as the program memory. Okay, so program memory, that will store the instructions, and data memory will store the data required to execute those instructions. Okay, so the data and instruction will be fetched from the primary memory, to the processor, and the processor will perform all these logical and arithmetic operations, and the result will be returned back to this memory once again. Okay, from this memory it will be transferred to the hard disk or the secondary storage devices like your tape drive, or and that is the magnetic disk drive, etc. So this is the basically structure. But how this CPU fetch cycle works? So the instruction and data fetched from this memory, executed and returned back to this memory. This cycle is known as the CPU fetch cycle. And how this is performed here by using this John von Neumann architecture, that is the point of discussion. So basically, the design of the programming languages are based on the architecture of the computer, right? So if we will think, last class I have told you, if we will think for the today's advanced Java programming, if you want to execute in a processor that is designed in the year 1950s, suppose a 4-bit processor or a 8-bit processor, will it be executed? No, it cannot be. The Java program cannot be executed, or the C program cannot be executed, because those programming languages will, those architecture will not support those programming languages. Okay, so let's see. So we have understood that the program and data are stored in the primary memory. That is the process of loading. So the loader is a program. The loader is a program which will load the program, that is compiled program, that is the object code, to the primary memory, and the program will be stored in the program memory, and the data required by that program will be stored in the data memory portion of the RAM, random access memory, or your primary memory. Okay, so the instructions and data will be fetched from the primary memory, will be executed. The instructions will be executed, and the data will be processed. So this process is known as CPU fetch cycle. Right. So this process is known as CPU fetch cycle. So fetch execution cycle on a John von Neumann architecture computer. Okay, so what is the algorithm? So algorithm is initialize the program counter, right? Initialize the program counter, repeat forever. That means till the completion of execution, till the completion of execution. Fetch the instruction pointed by the counter, increment the counter, decode the instruction, execute the instruction, and repeat. So this process is known as CPU fetch cycle, right? So increment the first fetch the instruction, that is pointed by the counter. Counter here means that is the program counter. Okay. So next, increment the counter. So after fetching the instruction, increment the value that is present in the counter. Then decode the instruction, execute the instruction, and write back the result to the RAM. And this process will be repeated till the completion of execution of the program. Okay. So anyone can answer my question. So what is a program counter? Anyone can answer. What is a program counter? Do you have any idea about what is program counter? Yes or no?
Sir,
Yes.
sir, it's a type of register, sir.
Yes, that is a register.
Sir,
Yeah.
yes, sir, which stores the location, maybe.
Which stores the location?
Location of the data.
The location of the data. Right. Okay, that is not okay. That is partially correct. Okay. So let's see. Let's discuss about that. What is program counter? So I hope most of you don't know what is this program counter. So we require a detailed discussion on this.
So it will store the instructions address, next instructions address.
It will store the address of the instruction to be executed next. Right. So let's discuss. The whiteboard is visible to all of you.
Yes, sir.
So let's start. So there are a number of special purpose registers are present. So here, this is your CPU as per John von Neumann's architecture. This is input and output devices. Okay, and this is your memory. This is primary memory and RAM. Or also your other RAM. Okay. So apart from this memory, primary memory, there is certain registers are present in CPU. So apart from this memory, inside CPU, some special purpose registers are present. Okay, special purpose registers. Right. So there are number of special purpose registers inside the CPU, central processing unit. Okay. So what is the work of this special purpose registers? These special purpose registers will work as the rough sheet or intermediate data storage registers for the CPU operations. Okay. So what it will do? It will work as intermediate storage required for execution of instruction. Right. Okay. There are number of special purpose registers. The special purpose registers are number one, the program counter. Program counter. It will hold the address of the instruction. Program counter will hold the address of the instruction jota that is present in the RAM. Okay, it will hold the address of the instruction that is the inside the RAM. Okay, which will be executed next. Right, which will be executed next. So first one is the program counter. Second is instruction register. Okay, so instruction register is a register which will hold the register after it is fetched from the memory. So when one uh, instruction will be fetched from the primary memory to the CPU, so the CPU will keep the instruction inside the instruction register. Understood? So after fetching one instruction, the CPU will put that register which is fetched inside the instruction register. Okay, so it is the register which will hold the instruction after fetched from the memory. After it is fetched from the memory. Just a minute. So after it is fetched from the memory, right? So the instruction will be stored in the instruction register. So understood? Next, number 3, memory address register, or it is known as MAR, memory address register, or MAR. Okay, it will hold the address of the instruction which will be fetched from the memory. Right? Next, fourth is data buffer register, where the data will be stored after fetched from memory or to be written back to the memory. Okay. And another one is another group of registers are there which are known as general purpose registers. General purpose register. Another some general purpose registers, a number of general purpose registers are there which will be used as just rough sheets. हम जल्दी rough कागज use करे, rough sheet use करे, सेमती CPU तक वो rough sheet हिसाब से use करे intermediate operation पे. For the intermediate operation, whatever data storage is required, that will be stored in this general purpose registers. Apart from this, there are a number of special purpose registers like stack pointer high, stack pointer, stack pointer. Stack pointer high, then stack pointer low, stack pointer low. So like this, a number of registers are there. So how these registers are working? Let's see. Okay. So here let's see, this is the program memory. This is the address and this is the instructions. Okay, so that from RAM the addressing start from 0th location. The first location is 0, then 0001, 1 byte, then 0002, 2 by 2. So like this, every location has an address. Okay, every location has an address. So like this. So here this is the program memory, and here from here the data memory started. Data memory started from here. Data memory. So let's say that is 5001, 5002, 5004. So what will happen? So the instructions, the program will be stored in this program memory here in this part. Okay. In this part the program will be stored, and in this part the data will be stored. So every data or instruction will be stored in a special location, and that location can be accessed by its address. Okay. So now this is your CPU. This is your CPU. Okay. The CPU has a memory address registers. Memory address registers. That means here the memory will be placed, the address of the memory location will be accessed, will be placed in this memory address register. This memory address register is connected with this. This is the memory interface, right? Connected with this. And here, this is the data buffer register. Data buffer register. So it is connected with this data buffer register. Fetch hela pare data guda seat rahibo data buffer register re rahibo. So this is your program counter. Okay. These are your special purpose registers. Let's say R0, R1, R2, R3 जोगुड़ा को हमारा प्रोसेसर कौन यूज करो रफ शीट बड़ा यूज करो प्रोसेसर यूज एज ए रफ शीट okay so next is your instruction register IR is the instruction register and here this is your arithmetic and logical unit and this is your control unit. Okay, so all are connected with the central bus. All are connected with the central bus. Okay, so to the central bus, everything is connected. So every address location can be directly accessed. So program counter. So whenever the program will be executed, the address of its first location. So at the time of loading, whenever your processor will load or the loader program of your computer will load a program to the primary memory of the computer, then the first address location where the instruction loaded is placed in this program counter. So program counter means it is a counter at every clock pulse. At every clock pulse, the counter will increase its value by 1. Okay, so let's see the clock pulses. This is the timing diagram. With the timing diagram T, it is 0. So first clock pulse. So PC gets the address of the first location 0000. So in the next clock pulse, this 0000 will be loaded to the memory address register. So will be loaded here to the memory address registers. So 0000 will come here and this will become 1 because it is a program counter. And 000 means this location will be set 00. Suppose here the instruction is RAB, right? So this instruction will be fetched and will be placed in the data buffer register. So this will come to data buffer register. यहाँ पे आ जाएगा. Okay, so from data buffer register, the processor what will do? The processor will decode this instruction. The processor will decode this instruction. So it is consisting of one instruction and some operands, right? This is the operand address and the operands are stored actually here in the data memory. So these two are separated. So the instruction part will come to the instruction register and the data part will be stored in any of these registers. In the next clock pulse, what will happen? This is 1, this is 2, this is 3. Next clock pulse, what will happen? The instruction will be executed. So ALU will perform the operations. And in the fourth clock pulse, it will then this 00001 will placed here and it will become 2. That means the second instruction will be instructed. In the next clock pulse, similarly, it will become 3 and the third instruction will be executed. In the next clock pulse, this 3 will placed here 3 and it will become 4. So in this way, the process will be executed. That means all the instruction will be fetched and all the instructions will be executed simultaneously. Any questions here? Any doubt? Do you have any questions here?
No, sir.
बुझिएला तो? That means
Yes, sir.
every time at every clock pulse, a instruction will be fetched. Which instruction will be fetched? That instruction address is present in the memory address register, and from where the memory address register gets the value, it gets the value from the program counter. And after program counter providing the value to the memory address register, its own value will be increased by 1. So every time it will be increased by 1, and it will go. This process will be continued until the last instruction of the program will be executed. So this is the process how the program fetch CPU fetch cycle works. Okay. So next come to our discussion. Right. So the CPU fetch cycle of a John von Neumann architecture computer. So first is initialize the program counter. So first, who will initialize the program counter? The loader actually. The loader, when you will load the program inside the primary memory, at that time this it will just load. It will just inform the processor that the address of the first instruction is this. So from this, the program counter gets the first value. So then what will happen? Fetch the instruction pointed by the counter. Fetch the instruction pointed by the counter. Process, it will be adapted that from counter to memory address register, and the counter will be incremented. Increment the counter, then decode the instruction. Instruction decode means the separate the operand and the operators. So operands will go to the data memory or the special power registers, and the operator means the instruction will go to the instruction register, and then the execution of the instruction. So this process will be continued forever till the completion of execution of the program. Right. So next is program methodologies and influences. In 1950s and early 1960s, simple applications worry about machine efficiency. So simple applications were there, but machine efficiency was very low, because at that time only 4-bit or 8-bit computers are there. Late 1960s, people efficiency became important. Readability, better control structure, structured programmings are involved. Different structure, that means loop structure, if else ladder, switch, go to. These type of statements are created. Okay, top down design and stepwise refinement is followed, so that it is also better for the programmers or the designers to design the program. Okay. Late in 1970s, process oriented data to data oriented data abstraction, that means the object based programming design has been started in late 1970s. That means the encapsulation, data abstraction means creation of a new data type, and encapsulation means adding some methods with the new data types. So that is known as encapsulation. Encapsulation means binding the new data type and the methods together. And abstraction is the process of creation of new data types. So this process has been created. So in mid of 1970s, so object-based programmings are developed. Okay. So where only we'll discuss about data abstraction. Sorry, data abstraction and encapsulation. So that is known as process oriented to data oriented, or that is object based programming languages, 1970s. And in the mid of 1980s, object oriented programming languages are there. So that is along with data abstraction, encapsulation, inheritance and polymorphism, and dynamic binding. Another thing is there missing. So dynamic binding. This concept is also added in the middle of 1980s. So it is the growth is simultaneously with the growth of the processors and other components of digital computer. Okay. Language category. Already we have discussed language categories. Language categories, number one category is the imperative programming language. The central features are variables, assignment, statements, and iteration, loop, for loop, do while loop, etc. Include language that support object-oriented programming. That could support the object-oriented programming. Include scripting languages. Include the visual languages like example C, Java, Perl, JavaScript, Visual Basic, .NET, C++, etc. Then functional programming language. Main objective is of computing is by applying functions to given parameter. That means main objective of the programming will be divided into a number of functionalities. Right. So C programming is one of the best functional programming language also. So the best is that is LISP, list instruction set programming language. Okay, list scheme. A logic rule based programming language, that is Prolog. Programming logic. Prolog means that is the programming logic. Okay, logic programming, rule based programming language, that is programming logic. This is design. So markup or programming hybrid language. Markup language, you know, that is for website designs, for data standardization of data, which will be transmitted over a network. Okay. So that is known as your markup language. Markup language are basically tag languages. HTML, hypertext markup language. Okay. So these languages are design later. So there are certain points which the discussion is required. That is language design trade-offs. So reliability versus cost of execution. Last class we have discussed about why is a C programming language is not reliable, because they have some certain demerits are there. And if you have designed something by using that language, at the end what happened? The program crashes. So the cost will be there along with the program readability. Example, the Java demands all references to array element to be checked proper indexing, which leads to increase the execution cost. Okay, so when the program will become large, or it will take more execution time, then the cost of execution will also be more. Right. Next is readability versus writability. APL, automated programming language, provides many powerful operations and a large number of new symbols, allowing complex computation to be written in a compact program, but the cost is poor readability. So whenever a number of new symbols will be included, and you don't know what is the meaning of those symbols, then definitely it will create problem for readability. So पढ़ी ताको बुझिबा बहुत डिफिकल्ट, जोटी गुडाए सिंबल यूज हेतबो जार मीनिंग तमे जानि नथिबो. You don't know the meaning of the symbols which that is used in the program. Okay, so next is writability or flexibility versus reliability. See here example, the C++ pointers and C pointers also. The C++ pointers are powerful and very flexible, but are unreliable. Very flexible for programming, C++ or C. Okay, but reliability is 0. You cannot rely on that C and C++ because of the pointers. If we minus these pointers and some of the statements, then this language is very powerful and flexible for programming. Okay, so different types of programs based on the implementation methods. So in implementation method means how it is compiled, how the source code is converted to the object code, how the source code will be converted to object code or machine code. Okay, compilation, programs are translated into the machine language or object code. Pure interpretation, programs are interpreted by another program known as interpreter. You know the difference between compilation and interpretation. Okay, do you know the difference? What is the difference between compiler and interpreter? In the class 10 or 11, 12, you are also, if you have IT, so you must have known. So compilation will take the whole entire program at a time and will convert it to the object code. But the interpretation will take line by line. Okay, and we'll convert it to this hybrid implementation system like Java programming. The Java programming consisting of both compilers as well as pure interpreter, which are known as hybrid implementation systems. Right, this is known as hybrid implementation systems. So next, layered view of computer. So the operating system and the language implementation are layered over a over machine interface of a computer. So this is the bare machine, or it is the core hardware. So this hardware is based on the micro instruction or interpreters, micro instruction set. So the operating system is based on this micro instruction set and working just above the core hardware. Operating system is providing all the resources. You know what are the services provided by the operating system. So out of the services of the operating system, the compilation, linking and loading, all these processes are also known as system processes. Okay, so the compilers, linkers, loaders, interpreters are a part of operating system, which are just working above the operating system core files, operating system kernel of the operating system. So this operating system is known as the kernel, that is the basic kernel. Okay, and above this kernel, the number of compilers, programmers, loaders are available. So this is the layer view. So first one is the core hardware machine. So above it, that is the micro instruction interpreter. That means whenever any processor is designed, a set of instructions are designed. Okay, a set of instructions are designed. So have you discussed in the computer architecture class about the RISC machines and the CISC machines?
No, sir.
Have you discussed the RISC and CISC machines? Discussion hela
No,
nahi?
sir.
No, sir.
Not till now.
Acha. A RISC instruction set means that is reduced instruction set computing. A RISC based computers, okay, reduced instruction set computing, and CISC, that is complex instruction set computing. Okay, reduced instruction set computing and complex instruction set computing. So in complex instruction set computing, huge amount of instructions are there. In case of this reduced instruction set computing, only 7 or 8 or maximum 10, 12 instructions are there, by using which all the programs should be written by using those instructions. So which one is easier to program? RISC machines or CISC? Which you will prefer to program? Which you will prefer to program?
Sir, RISC machine, sir.
RISC. RISC or
Yes,
CISC?
sir.
RISC. Why
RISC, sir.
RISC?
Sir, it will be reducing size, sir, programming.
Not reducing size. It is reducing. It is of equal length, not size. It is of equal length. That means all the RISC instructions are of equal length. There is a power failure here. Okay. So I will stop this class here. Next class we will discuss about that more on this. Any question?